In this video, we'll look at how to prove Heron's formula, which is a nice extension of the law of cosines, or at least relevant to the law of cosines. So we'll do a quick proof and end with the formula itself. Consider this triangle. We want to find a definition for the area of this triangle that is equivalent to the definition that we've already talked about. So let's start with that one. Let's start with A equals 1/2 AB sine C. Let's square both sides. So we have A squared equals 1/4 little a squared, little b squared, and then sine squared C, which by our Pythagorean identity, which says that sine squared C plus cosine squared C equals 1, we can say that this equals 1/4 a squared b squared 1 minus cosine squared C. And then since this is a difference of two squares, we can factor it. So we have 1/4 a squared b squared 1 minus cosine C and 1 plus cosine C. So now we're going to write each of 1 minus cosine C and 1 plus cosine C in terms of A, B, and C. Let me switch colors. So first we want to start with the law of cosines that includes cosine of C. So let's say C squared equals A squared plus B squared minus 2AB cosine C. So we need to isolate C, so we need to subtract over A squared and B squared. We'll go ahead and multiply by -1 too. So that will leave us with an A squared plus B squared minus C squared equals 2AB cosine C. So this implies that we have cosine C equals A squared plus B squared minus C squared over 2AB. So then, naturally, 1 plus cosine C would equal 2AB plus A squared plus B squared minus C squared over 2AB. And interestingly, this can be factored. So we can factor this as, first we need to just look at this. That looks like an easy thing to factor to me. That looks just like A plus B quantity squared minus C squared over 2AB. And this is a difference of two squares. We have A plus B quantity squared minus C squared. So we'll write that as A plus B plus C and A plus B minus C all over 2AB. Following the same process, I won't do it again here, but we end up, if we do 1 minus cosine C, we end up with C plus A minus B, C minus A plus B all over 2AB. Okay, so we're almost there. We'll copy where we left off, right here. We'll slide down, put that here. So remember, this was the A squared. This is the area squared. Now we'll substitute in these two equations for 1 plus cosine C and 1 minus cosine C. So we have A squared equals 1/4 A squared B squared. And then all of this. So we have A plus B plus C, A plus B minus C all over 2AB. And then we have C plus A minus B and C minus A plus B all over 2AB. Now we gotta see if anything cancels out. Well, it looks to me like we've got a 1/4 A squared B squared. So this A squared B squared here will cancel those two ABs. And if we have 1/4 over 1/4, we can kind of think of that as being a distribution of 2's along this, and this term. That is, that we'll write it out like A plus B plus C over 2, A plus B minus C over 2, C plus A minus B over 2, and C minus A plus B over 2. Now here's kind of the kicker. If we define something that's called the semi-perimeter of the triangle, if the semi-perimeter is 1/2 a plus b plus c, and we let that equal s, then we can simplify a whole lot of this. So we will have literally kind of half the perimeter. So now if we substitute this into what we currently have for our area equation, 1/2 a plus b plus c is our first term, so that's s. And then you can think of the next one as being s minus c. So we have s minus c, then we have s minus b, and s minus a. And the very last step, take the square root of both sides. So we have s times s minus a, s minus b, s minus c. Whew. All right, so this is another equivalent expression for the area of a given triangle. To summarize, what we did is we started with our original definition of the area of a triangle using 1/2 AB sine C from a previous video. Did a little bit of trigonometric identity substitution, factored, used the law of cosines to come up with something that we could substitute into this factored form, and then did a little bit of algebraic manipulation, then using the definition that the semi-perimeter is 1/2 times a plus b plus c to arrive at Heron's formula, which says that the area of triangle ABC is given by a equals the square root of s times s minus a times s minus b times s minus c, where s is the semi-perimeter of the triangle. That is, s is half the perimeter, so s equals 1/2 a plus b plus c.